Hi everyone, my name is Sherry Yang. I will be presenting our work on trail near optimal imitation learning from suboptimal data. This is joint work with Sergey Levin and Ophir Nahum. Imitation learning aims to recover an optimal policy pi star from expert demonstrations. The behavioral cloning approach to imitation learning uses expert actions as labels to learn a supervised policy. These expert labels are, however, hard to obtain in practice. On the contrary, an application could have produced large quantities of suboptimal offline data. Such data should not be directly imitated because they are suboptimal. This work focuses on learning a reparameterized action space from these suboptimal data to provably accelerate behavioral cloning from experts. Additionally, we want this reparameterized action space to avoid the mode collapsing issue as in VAE-based latent skill extraction methods. We propose trail for learning this reparameterized action space. During pre-training, trail first learns a factor transition model on suboptimal offline data through KL divergence minimization. The factor transition model consists of an action representation function phi and a latent transition function tz. Trail also learns an action decoder to recover original actions from reparameterized actions, also during pre-training on suboptimal offline data. During imitation learning, Trail learns a latent policy pi z through behavioral cloning in the reparameterized action space. During test time, Trail samples a latent action from PyZ and applies the pre-trained action decoder to recover an expert action. Our theorems show that the trail objective minimizes an upper bound between the decoded latent policy and the expert policy. Sample analysis suggests that trail offloads the complexity from imitation learning to pre-training, where a large amount of suboptimal offline data is available. So the third term after the C3 is in the lower dimensional Z space as opposed to the original dimension of actions. This analysis is for when the latent actions are discrete. What about continuous latent actions and stochastic expert policies? Well, we show that trail's upper bound also holds in continuous latent action space, under the assumption that the transition model is linear. Furthermore, we show that a deterministic latent action is sufficient to model any stochastic expert policies under this linear dynamics model assumption. Recall the behavioral cloning loss in the discrete latent action space without the linear dynamics model assumption. Notice that this assumption also leads to an easier optimization problem, as we're now minimizing the gradient norm of a quadratic function, which can be easily achieved by any gradient descent methods. To learn trail in practice, we parameterize the factor transition model as an energy-based model and use a temporal contrastive loss to learn phi. When the latent action space is continuous, we can apply random Fourier features to obtain and approximate linear dynamics model. Both pi alpha and pi z are neural network parameterized Gaussian policies in trail. Our experiments on D4RL and maze shows that trail performs better than latent skill extraction methods such as opal and spiral. Further experiments on the control suite shows that trail has comparable performance with offline RL methods, suggesting new ways of utilizing offline data other than doing offline RL. Thank you, and please check out our paper and code.